So our team today, we have myself, Leon Youngs. I'm Head of Sustainability Services here for Tuxford in the UK. And as you can see from my photograph, I enjoy my job immensely. We form part of the Green Energy and Sustainability business area, which includes other service offerings related to CCUS, hydrogen, and also renewable energy. This is the first of a series of webinars that we aim to deliver in the sustainability area. And this one focuses on three specific topics where we have tools and experts that can support you. On that note, I'll hand over to my colleague, Divyanshu, who's your presenter for today, and I'll see you in the Q&A session at the end.
Hi, everyone. As you can see my photo as well, I am Divyanshu Sethi, and I'm a chemical engineer by background. I did my master's in climate change finance and investment from the University of Edinburgh. I have a working experience in voluntary carbon market rating company as an analyst. I've worked as ESG and carbon footprint consultant for a think tank, and now working as a climate action and sustainability consultant at Tuxford since October last year. At Tuxford UK, we are providing advisory services, which include consultation on sustainability delivery plan and on carbon reduction plans to the customers to help them in their net zero journey. In addition to this, we also provide consultation on environmental issues. We also perform carbon footprinting for corporates. We also perform product carbon footprinting, partial product carbon footprinting, and do critical review for the same to assess if the process followed for the calculation is aligned with the standards or not. So today we are going to discuss these three different topics, which are like carbon footprinting, life cycle assessment, and Tuxford's own UNSDG mapping tool. So first we'll be discussing carbon footprinting. But before that, we'll start with understanding actually what carbon accounting is, then move on to carbon footprinting, what the global warming potentials are, what is the typical process of carrying out a carbon footprint, what are the plausible benefits of carrying out carbon footprint exercise, how it is carried out, and what are the usual mistakes clients make. So this will come from like our experience in the industry, and that's what like we flagged in the presentation as well. Then we'll discuss the life cycle assessment, different stages involved in life cycle assessment, uses and limitations of life cycle assessment, why it is important to use a tool instead of using an Excel spreadsheet to calculate emissions. Then I will give you an overview of the tool that Tuxford UK uses for life cycle assessment and carbon footprinting. Then, as I told you that Tuxford has its own UNSDG mapping tool. So we think like this will be very beneficial for the companies want to track their contribution towards 17 Sustainable Development Goals described by the United Nations. And I will explain the 5-step process that we use to measure the sustainability based on UNSDGs. And then we'll open the floor for the Q&A, where you can send us questions through the chat, and we'll try to answer them all. So first, before moving to carbon footprinting, it is important to understand what actually carbon accounting is. So carbon accounting is used by analysts and management teams to understand the extent of an organization's carbon emissions. Carbon accounting is also referred to as greenhouse gas accounting. It is because there are 7 direct greenhouse gases under Kyoto Protocol that we account for. So it's the gases are carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen trifluoride. There were only 6 gases that were considered as direct greenhouse gases by Kyoto Protocol when it was first adopted in 1997. And then they amended it, and they included nitrogen trifluoride in in 2013 during Doha Amendment. Carbon accounting. So this is all about carbon accounting, and now what actually carbon footprinting is. So it is the total amount of greenhouse gas emissions expressed in terms of carbon dioxide equivalent produced by an individual, an entity, or an organization. The carbon footprinting is aligned with the ISO standards and also GHG protocol. We keep like track of these things because we think that it is good to have if it is good to produce your carbon footprint against like which is verified against any standard, and we help companies to align their carbon footprint to ISO 14064 Part 1 specification, which includes a specification with guidance at the organization level for quantification and reporting of greenhouse gas emissions and removals, and GHG protocols, corporate standards, and corporate value chain Scope 3 standard. So now we'll discuss a bit about global warming potential. This is very important, and this is, I think, like we have came across a lot of issues with global warming potentials, and this is where like our clients go wrong. So global warming potential is the amount of warming a gas causes over a given period of time, usually over 100 years. The Intergovernmental Panel on Climate Change, IPCC, publishes these GWPs of different global different greenhouse gases over 20, 50, 100, and 500 years in their assessment reports. So there are 6 assessment reports available until now. The latest one is AR6, which is Assessment Report 6. Global warming potential is an index with carbon dioxide having index value of 1. And global warming potential for other greenhouse gases is the number of times, more or less, warming they cause as compared to carbon dioxide. The table on the right presents the global warming potential from IPCC AR6, which is the latest published report. So just on this one, I will just tell you like, so carbon dioxide, as I mentioned, is having like the index 1, and then methane is 27.9 times more potent than carbon dioxide over 100 years lifetime, and nitrous, and in same manner, nitrous oxide is 273 times more potent than carbon dioxide in causing global warming over 100 years. So why do we need to do carbon footprinting? Why there is a need of like doing this exercise? Carbon footprinting helps us in quantifying the emissions of an individual entity or a company. This subsequently helps us find out the hotspots, which means the area where the emissions are more than normal, or the areas that need special attention in the future. You will come across this word hotspot a lot during the presentation, or like even this terminology is used within the industry a lot. So we think that what get measured could be reduced. So when we know what the source and sinks are, we can pave a path to get to net zero goal by making an emission reduction plan and assess it over a period of time to track progress. This also helps companies to calculate the abatement cost by shadow carbon pricing. Due to increasing cost of carbon credits in the voluntary carbon markets, as well as reducing number of carbon credit allocation in the compliance market year on year, where the ETS is implemented. For example, in Europe or in New Zealand, in the US, there are some parts where ETS is implemented. So it actually reduces the allocation of credits to the companies year on year, and it could have a negative impact on the company's income by increasing because this will increase the expenditure on carbon credits. If the companies would not be able to reduce the emissions and buy credits, this cost could pass on to the consumers, and the companies performing better in the carbon emission reduction front in the same sector will have an advantage and would attract the consumers. Therefore, shadow carbon pricing could help assessing the abatement cost and also the financial risk. Carbon footprinting could help companies to allocate the responsibility to reduce emissions to different sections of the company. It can uh, also be useful in like comparison of comparison of carbon footprints over the year could help companies track their progress and help them to be aligned with the Paris Agreement goals. It can also help understand supply chain risks and help setting the carbon budget and targets. Carbon footprinting can help in taking the marketing and consumer related decision. Um, this can help you build trust amongst your customers by establishing that you are more sustainable as compared to others. This enhance your brand value and help you winning tenders when you are doing like business to business work. Through and it will give you like a better positioning within the industry. So, what does the carbon management journey look like? So, it is a 11-step journey that we have made within two suit. And so, first is setting up the organizational boundary. This includes operations, ventures, subsidiaries that are to be included within the scope. And then we and then setting up of operational boundary, which includes decision on what emissions scope, what scope of emissions the company wants to include. So, like if they want to include scope 1 and 2, or if they want to include scope 1, 2, and 3. So it's this, like you take decision on this stage after setting up the organizational boundary. You set operational boundary, and then you define the time period, which usually is a calendar year. And then the step 4 is a collection of activity data. So this includes collection of data of fuel used by a company's own vehicles, electricity used, upstream, downstream transportation, employee commuting, business travel, etc. Then application of emission factors and takes place. For example, within the UK, the BEI provides emission factors, so you can either use that, or you can have your own emission factors, or can refer to some other emission factors as well, depending on the location, like the geography where you are working in. And this includes the use of this step also includes the use of global warming potential, because different processes has like different types of emissions. So we consider like 7 greenhouse gases, like direct greenhouse gases, which are specified under Kyoto Protocol. So you need to multiply global warming potential for gases other than carbon dioxide. So you multiply global warming potential, and then you get the emissions, the total emissions, and you convert them into carbon dioxide equivalents. And then we do internal reporting. At this stage, the carbon accountant prepare a report and share it internally. Then verification takes place as per the standards. As I mentioned, for carbon footprinting, we do verification as per ISO 14064-3, but look into like alignment if it is aligned to ISO 140641 or not, and GHG protocol. And then the report is shared in public domain, and then target setting is carried out within the company to attain the carbon neutrality and eventually net zero goals. So this figure presents like a organization chart, I would say, and uh, now I will explain more about what actually organizational boundary is. So when we carry out a carbon footprinting exercise, we determine the scope. This includes deciding organizational and operational boundaries. First, we set the organizational boundary. So organizational boundary, we said it like depends on so business operations vary in their legal and organizational structures. They include wholly owned operations, incorporated and non-incorporated joint ventures, subsidiaries, and others. For the purpose of financial accounting, they are treated according to the established rules that depend on the structure of ventures, subsidiaries, and others. Um, in setting organizational boundaries, a company select an approach for consolidating greenhouse gas emissions, and then it consistently applies to and it consistently applies the selected approach to define those businesses and operations for the purpose of accounting and reporting greenhouse gas emissions. The operational boundary includes then comes the operational boundary. The operational boundary includes the decision on including what sources and sinks of emissions and reductions within the scope of the work you want to consider. So scope 1 or 2, scope if you want to include scope 3 as well. So the decision for including that scope is taken and like after taking decision on organizational boundary, and that's the second step in carbon management plan. So there are two different approaches that can be used to consolidate greenhouse gas emissions. One is equity share approach, and the other one is control share approach. If the reporting company wholly owns all its operations, its organizational boundary will be the same, whichever approach is used. For companies with joint operations, the organizational boundary and resulting emissions may differ depending on the approach we use. So, in both wholly owned and joint operations, the choice of approach may change how emissions are categorized when operational boundaries are set. So under equity share approach, a company accounts for GHG emissions from operations according to its share of equity in the operation. The equity share reflects economic interest, which is the extent of rights a company, which is basically like extent of rights a company has to the risk and rewards flowing from an operation. Um, and then under control approach, a company accounts for 100% of greenhouse gas emissions from operations over which it has control. It does not account for greenhouse gas emissions from operations in which it owns interest but has no control. But this does not work same for oil and gas industry, because like in oil and gas industry, often they have like complex ownership and operationship structures. Thus, the choice of this control criterion in oil and gas industry can have substantial consequences for a company's greenhouse gas inventory. In making this choice, companies should take into account how greenhouse gas emission accounting and reporting can best get the requirement for of emissions reporting and trading schemes, and how it can be aligned with financial and environmental reporting, and which criterion best reflect the company's actual power of control. So now let's move on to like how we calculate emissions. For carbon dioxide, we calculate emissions directly, like by multiplying activity data with emission factors. There's no use of using global warming potential here, because carbon dioxide have global warming index as one. So there's no need of using global warming potential here, but it could be used as well. It is anyway, it is one. And then for gases other than carbon dioxide, the calculation is carried out by multiplying activity data, multiplying activity data with emission factors with an additional factor called global warming potential here, which gives you the emissions in carbon dioxide equivalent. So there are two types of approaches that can be used to consolidate data. So one is centralized approach, and the other one is a decentralized approach. In the centralized approach, individual facilities report activity data to the corporate level, where greenhouse gas emissions are calculated. In the decentralized approach, individual facilities calculate emissions and feed it into a corporate level. Under both the approaches, the staff at the facility level collects the activity data. The difference between the two approach is in where the emission calculation occurs and what type of quality management procedures must be put in place to on each level of the corporation. So now let's talk about data, which is like a very hot discussion within our teams within TÜV because we focus more on data, and we really think that it is the building block of any calculation. So like if you want to carry out a life cycle assessment or carbon footprinting, product carbon footprinting, whatever it is, data is the building block, and it should be correct and it should be understood in a better way. Therefore, like we are going to discuss here about data. So there are two types of data: primary data and secondary data. So the data is collected. The data that is collected directly from the sources is called primary data. And I can give you some example for this is mileage recorded for from a company vehicle, and meter reading for energy consumption, etc. And the data that is gathered from studies, surveys, and research such as government publications, websites, journals, books, and articles is called as secondary data. This is used more specifically in the calculation of Scope 3 emissions, where the emissions from supply chain is not available, and it is difficult to gather that data from the supplier. Now, here is an example of what goes wrong when we calculate emissions using an Excel spreadsheet. So in the Excel spreadsheet published in BEIS, if you'll see, I've made like a comment here that this is wrong, and this is what a lot of companies do, so if you'll see here, I don't know, like I think it is too small, but here it says that in the Excel sheets published in BEIS, the conversion factor is 0.16983, and it should be that, but because we are humans and we make mistakes, so when we use Excel spreadsheets, it is very inevitable that there are a lot of mistakes because you are transferring data from one cell to another, and sometimes you just look into data and then you just write it down, like which is called hard coding. So it is very very common amongst customers, and this is because of human errors. So these are the mistakes that people do. And also, like if you'll see the sources of emissions, it's available only for one, but it should be available for all the activity data, like for all the emission factors, like where you have collected that emission factors from. So it should be presented in this way. So uh, a carbon accounting, or like the carbon footprinting exercise, should look like this. The result will be the carbon footprint of this exercise. Now we'll move on to life cycle assessment. So life cycle assessment is relatively a more complex, relatively more complex than carbon footprinting. It is the compilation and evaluation of inputs, outputs, and potential environmental impacts of a product system throughout its life cycle. It is considered a much wider it is considered a much wider range of considered a much wider range of aspects than just carbon footprint, and can include things like water footprint, emission related to raw material extraction, emissions from use phase and disposal. The life cycle technique will with proper justification can be can be applied in studies that are not life cycle assessment or life cycle inventory studies. For example, cradle to gate studies, gate to gate studies, cradle to cradle studies, and specific part of the life cycle. Example, waste management components of a product. To carry out life cycle assessment, international standard ISO 14040, which describe the principle and framework for life cycle assessment, and ISO 14044, which specifies requirements and provides guidance for life cycle assessment, are referred to. There are 4 phases in a life cycle assessment study. So first is the goal and scope definition phase. Second one is the inventory analysis phase. Third one is impact assessment phase, and the ultimate one is the interpretation phase. The goal and scope include system boundary and level of detail, the depth and breadth of life cycle assessment. Can differ considerably depending on the goal of a particular life cycle assessment. Life cycle inventory is an inventory of inputs and outputs data with regard to system being studied. It involves the collection of data necessary to meet the goals of the defined study. The purpose of life cycle inventory assessment is to provide additional information to help assess a product system's life cycle inventory results, and so as to better understand the environmental significance of that product. In the assessment phase, the result of life cycle inventory or in life cycle inventory assessment, or both, are summarized and discussed as a basis for conclusion, recommendations, and decision making in accordance to goal and scope of definitions. So why there's a need to do of life cycle assessment? Life cycle assessment helps in making decisions for customers and for businesses on which product and supplier to buy from. It provides opportunities to improve the environmental performance of a product at various points in their life cycle. It helps informing decision makers in industry, government, or non-governmental organization. For example, for the purpose of strategic planning, priority setting, product design or redesign. It helps in setting target to reduce emissions from a specific life cycle phase and tracking progress over time, and also assist in the selection of relevant indicators of environmental performances, including measurement techniques and marketing. Example, implementing an eco-labeling scheme or something like that. Life cycle assessment Lifecycle assessment does addresses the environmental aspects and potential environmental impacts uh, from from use of resources and environmental consequences, but it does not show system-wide changes caused by decisions and cannot be used on its own to select a mitigation action. So here we are going to discuss the benefit of using an established tool instead of Excel. So for an established tool to carry out greenhouse like to carry out carbon footprinting, could minimize the human errors and could be easy to trace. For but as compared to the GHG calculator, MS Excel involves a lot of manual errors, which are difficult to trace. It is easy to analyze data with the dashboard and graphical presentations of data in the calculator, but in Excel sheet you need to make dashboards on your own, and then it takes a lot of time to create those dashboards. But you can do it using Power BI, but it takes a lot of time, and issues cannot be resolved if like it is very difficult to trace the issues then. So GHG calculator includes a powerful relational database with database designed specifically for environmental or carbon footprint calculation, and they have designed a powerful, so the tool that we use, so our provider has designed a powerful searching tool taking advantage of the relational database structure. In MS Excel, too many databases are like there are too many databases are available, but in MS Excel, if you will try to download it and like try to put it in a sheet, then it will be very difficult to handle. GHG calculator is efficient, as I said. You can use the emission factors directly from like a drop down list. You can use whichever global warming potential you want to use. We recommend using the latest global warming potential, but let's say if you want to use global warming potential from AR4 or AR6, you can just change the global warming potential by a drop down list, and the whole calculation will change by itself. But for MS Excel, you need to either do like changes by yourself going into each cell, or you need to then you need to use a formula, or you need to reference that cell again and again, which is again a very tedious task. And it is very easy to prepare reports, and it takes a few minutes using a GHG calculator. But in MS Excel, you need to prepare a report separately. It does not create any report. So why do we use a tool? The use of tool make it easy to analyze the data because of the dashboard, as I mentioned earlier as well. It helps us to compare the graphical representations, emissions very easily. It helps us improve data collection and data management, and help in communicating the results by creating reports very easily. So this is the introduction to the tool that ToolSuite UK is currently using. The tool that we have is a multi-sectoral software for performing life cycle assessment and carbon footprinting. So it's a one-stop kind of tool which help, like we can perform life cycle assessment and carbon footprinting in the same tool. It helps us in calculating, analyzing, and reporting environmental impacts according to multiple international standards, and it helps calculating environmental carbonic and hydric impacts. It has an extensive database of emission factors, especially the emission factors from Global South, and compiling Excel sheet takes too much time and could lead to errors during compilation. So the tool is fast in calculation of results, and there is no need of compiling Excel sheets. In this, the tool presents main methodologies: EF 3.0, ILCD, International Reference Lifecycle Data System, and CML, Chain Management by Lifecycle Assessment, and IPCC or Recipe. It also incorporates the EcoInvent database for the analysis of Environmental Protection Energy Agency for EPA. In addition to these well-known databases, it is also possible for users to create their own databases and share them with other users. And it is very easy to add information from databases like Gabi and USLCI. So here is an example of life cycle assessment using the tool. So here I carried out a life cycle assessment for strawberry production, which involves like 4 major sources of emissions, and which are emissions from material used, agricultural product used to grow strawberries, cultivation and processing of strawberries, and packaging of strawberries. So on your left, you can see the emissions from materials, including emissions from plastic, steel, glue used, and its transportation to the site of production. On the top is the emission from agricultural products like saplings, fertilizer, disinfectants, and treatment chemicals, and their transportation. In the middle is the emission from cultivation and production, and at the bottom is the emission from packaging of strawberries. And the total emissions from the production you can see here at the bottom. Here you can see the total emissions per kg of strawberry production, that is 330.526 grams carbon dioxide equivalent. Now let's move on to our last tool, which is UNSDG mapping tool. So there are 17 goals described by the United Nations that describe the each facet of sustainability, that is social, economic, and ecological aspects. Each sustainable delivery goal each sustainable have targets. Each SDG has targets and indicators. There are 126 targets and 1,533 indicators in total. The UN SDGs are acceptable by 193 countries, and this tool provides full transparency, traceability, and comprehensive. The UN SDG mapping exercise is carried out in 5 steps. First is weighing SDGs, then collection and preparation of evidences for sub-goal indicators, then rating, reporting, and providing recommendations, and then presentation. The SDG weighting, the first is SDG weighting, and the SDG weighting is divided equally into 3 different weightings. First is universal weighting. The second one is industry weightings, and the third one is regional weightings. Each of them makes 33.3% of the total weight, which is 100% weight. Universal weightings is the weighting of the SDGs based on the number of interrelationships between the SDGs. This means that how much, let's say for an example, how much SDG 1 is related or being referred to in other SDGs. So this is how like we describe the importance of that sustainable delivery goal. So this is based on interdependently scientifically proven evidences, and this weighting depends on which SDG has more weight and stronger influence on other SDGs. The second one is industry weighting. It is the weighting of the SDGs based on the observation limits. This is weighted from an interdisciplinary committee of experts, or an expert survey. So we sit together and we discuss, and we look into like different research papers. In this also possible, all possible SDG pairing are examined, and experts do a research on which SDG is more important, less important, or equally important in relation to the observation limit. Regional weighting is based on the region in which the assessed company is located, and this is usually from like a sustainable development report. This comes from the sustainable development report. For example, as you can see here, there are 5 targets available in SDG 1. Each target have different number of indicators. So let's say if there are 10 indicators within target 1, so the weighting of each indicator within the target will be equally divided. So let's say for target 1 it will be 10% each. For target 3 here it's 100% because there's only one indicator. So on and so forth. Each indicator is weighted equally within one target, as I mentioned, and each indicator justification document is graded from 1 to 5 points. I can show you here 1 to 5 points, and one indicates the document provided are inadequate to fulfill the need, and 5 being availability of all the documents. And rating scheme is based on scientific research study or industry benchmark. So here's this example. As I already mentioned, it's for example, if there is like fair prices paid, so this is a target. The rating could be from 1 to 5, depending on like how the documents are provided and how fair the price is paid. For results, weighting for each SDG is multiplied to its fulfillment, and total contribution is found out. The fulfillment is based on the evidences available, and weights are found out using the SDG weighting mechanism. If we map all SDGs, then in the end, the result means that means that the company's sustainability performance within the boundaries is 82%, which you can see is presented in the table. It is holistic because we use all SDGs and therefore cover all aspects of sustainability. If we cross out some of the SDGs, sustainability will not be representative, and we'll get some kind of performance. We will not get like the holistic view of the sustainability. So we try not to do that. Some companies work towards specific SDG goals. It is difficult to find the sustainability level achieved using this tool, because in our final result, this will not lead to a holistic view of on sustainability if we do not cover all the ESG aspects. In this case, we need to write a detailed report stating that within the system boundaries that contains these topics, the result is X%, and another information that this is not a holistic view on sustainability and can't be used as a result or published in public. So we don't recommend to do it in this way. We shift it to an ESG view and cover all aspects with different SDGs under ESG aspects. But this would be another method. We use ESG framework and not SDG assessment tool for that. We don't rate the overall score, that is performance, that is if the performance is good or bad or need some more improvements. That is not our goal to tell someone if they are good or bad. So you can see the diagram that there is like dark greener, the result is dark greener here. If you'll see the map, uh, over 80% it is dark green, light green, and yellow for 60 to 80%. But there is no such thing as good or bad, or a threshold. So we just state that the current situation of your working towards SDGs is looking like this. In phase 4, reporting and recommendations are provided based on the assessment. This includes the description of the observation limit for the sustainability assessment, presentation of observation limit for the sustainability assessment, and presentation and detailed justification of SDGs ratings. Uh, then it also involves determination of results per SDG, which evidence document was rated, and why and how highly it is rated. Then recommendations are provided on how to improve the results, and overall results of the sustainability is provided. Then at the end, the ultimate step is the phase 5, which includes presentation of report and results online via QR code on our website, as well as traceability of the improvements in the respective SDGs over the years. That's from my end. Thank you so much. And now Leon can come in.
Yes, well, I can't see any questions in the chat, so I'd just like to say thank you very much to Divi for taking the time today to present to you all, and thank you to everybody for joining and for people who watch this later. Hope you found it informative today. But I ask you to look out for future webinars. As I said, this is the first in a series, so look out for future ones. We would encourage people to contact us. My email address is at the end of this presentation. We've also got an info link you can join. You can send an email to us from. And just at the end here, we've decided to start giving some of our training courses away to people who attend our webinars as well. So if you'd like to partake in one of our training courses, we have some free learning courses there that you can use a QR code to sign up for. But